Okay, so do you see, look down here at angle number 1. So these little people in here, their line of sight is this horizontal line. Does everybody see that? Okay, and then the angle of elevation is defined as the angle from the horizontal up to what they're looking at. Okay, so that is our angle of elevation. Now, if I look at this little guy flying the plane, his line of sight, horizontal, is this way, right? And then angle 2 goes down from that horizontal down to the little folks in, what do you call that? Little space tower. Okay, this is the angle of depression. It's probably like a control tower. It's probably not space tower because that's just an airplane, right? It's not a rocket ship. All right, so angle of elevation goes up from the horizontal, right? Okay, angle of depression goes down from the horizontal. It's always from the horizontal. We never go from the vertical. Okay, so if we're looking at this angle right here, that's nothing. That's not an angle of depression or elevation. That's a garbage angle because it's off of the vertical. Put your phone away in your bag. Good. Thank you. Okay, so this is nothing. This one over here, also nothing because it's off of the vertical. We always take angles of elevation and depression from the horizontal. Cool? Cool. Okay. That's the part that used to mess me up when I was a kid, so just checking. Oh, sorry. Okay. Since these horizontal lines are parallel, our angles 1 and 2 are congruent to each other by the alternate interior angles theorem. So if I look at my two parallel lines, because they're horizontal, they're both parallel, they both have a slope of 0. Here's the interior, right? Okay, and they're on alternate sides of my hot pink transversal. That's the transversal. It is now. Okay, so they're congruent to each other. Okay, so let's look at this fun mess. So is angle 1 an angle of elevation or an angle of depression? Yeah, so we find the horizontal. Whoa, that was gross. Okay, and angle 1 comes down from the horizontal, so it is an angle of depression. Is there abbreviation for that? No. No. I mean, there can be for your notes, but not if you're writing it on the test. Does that make sense? Okay. All right, what about angle 4? Yeah, elevation. Angle of elevation. Are you guys going to be great at this or what? It's looking that way. All right, so we got to classify each angle as an angle of elevation or as an angle of depression. All right, what about 5? Elevation. Oh, wait, no. It goes down from the horizontal, so it is an angle of depression.
So down is depressed, up is elevation.
Yeah, is that a surprise? Is that a surprise?
No. Who came up with that? Yeah, their mom.
Well, it's because they all come from the same roots. You know what I mean? Like down, depressed. You know what I mean? They come from the same roots in Latin. or whatever. Okay, what about angle 6?
Angle of elevation.
Yes.
We have my angle up.
On your notes, I don't know that I'm going to police that, but on your test, if it gives you the options, I want you to write it out. Okay.
Yeah.
All right, you'll be fine. You'll live. If that's the worst thing that ever happens to you, you will have lived a charmed life. That's what my dad used to say to me. Okay, so the Seattle Space Needle casts a 67-meter shadow. Okay, that's here. This is the shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? I made the shadow.
No. So by Space Needle? Oh yeah. And the thing there's a line under.
Oh yeah, I don't know. I don't know what the deal is with that. Okay, so this is an angle of elevation because it comes up from the horizontal. Okay, how tall is the Space Needle? And we have to round to the nearest meter. Okay, so this is the height. So I have a right triangle because the Space Needle goes up vertically to the ground, which is horizontal. So I have a right triangle. So I'm allowed to use my trig. If I'm looking at my 70-degree angle, what is this side? Yeah, this is the opposite. Okay, this is my hypotenuse, which I don't really need right now. And then this is my adjacent. So if I'm thinking about which of my trig ratios, so TOA uses the opposite and adjacent, it's my tangent. So I'm going to say the tangent of my 70 degrees equals my opposite, which is y, over my 67. Now all I have to do is get y alone to find the height. So how do I undo dividing by 67? I multiply by it. So my y is going to be 67 times my tangent of 70 degrees. Now before you do this, make sure your calculator is in degree mode. So go to mode, make sure that you're on degrees. See, I'm already on radians. I'm messing up already. Okay, find your calculator. All right, so what did we say? 60.
67.
Okay, thank you. 70. Oops, not 700. I was trying to do parentheses. Okay, I got, what does it say to round to?
Nearest meter.
Nearest meter, so 184 meters. Okay. So y equals 184 meters. So now we have to write a sentence because these are word problems. So the Space Needle is 184 meters tall. Or 184 meters long if you knock it over.
Did you hear me say that?
Yeah.
I was like, never mind.
Just push it over. It's fine.
Like, never mind.
Okay. Not done?
I thought we were
Okay, let's try another one. Suppose we have a plane at an altitude of 3,500 feet. That doesn't seem high enough. And the angle of elevation from the airport to the plane is 29 degrees. Okay, so here's our little plane. What is the horizontal distance between the plane and the airport? So we know the height of the plane. We know the angle of elevation from the ground at the airport up to the plane. So when I look at my 29-degree angle, I have an opposite and I don't know the adjacent, but I can use the ratio that uses opposite and adjacent to find it. So if you think about,
Tan.
yep, so TOA, we're going to use tangent. Tan uses opposite and adjacent. So I'm going to do tan of 29. I don't know. What?
Equals.
Okay. Longest video ever. All right, so opposite goes on top. That's the 3,500.
X.
What?
I thought it was X on top.
Not always. You have to go with what the trig ratio says. The tan is defined as opposite over adjacent. And the last time we lucked out because our unknown was the opposite. That's why we got to put the variable on top. But it's not always the variable on top. Okay, so we got the 3,500 on top, the x goes on the bottom. Now, I showed you a trick in our last notes for getting the x on top.
With the
Yeah, we can either cross multiply, okay,
butterfly.
or remember that we can just trade these two in their spots. You guys remember that? Okay, no one's paying attention to me. Put your phone away. If I had paper, I would throw it at you. All right, so we can just trade these two in their spots because that's like multiplying both sides by x and dividing both sides by the tangent of 29 degrees. So now I have x equals 3,500 divided by the tangent of 29 degrees. Okay. We can just put that in the calculator. 3,500 divided by the tangent of 29 degrees. 3,500 divided by tangent, what was it, 29, 39?
29.
29?
6, 3, 14.
Okay, what does it say to round to?
Foot.
Okay, thank God. Okay. 6,314. Jeez Louise. Okay. So my x is 6,314, is that right? Feet. And it's a word problem, so I need a sentence. So not the diagonal distance, but the horizontal distance from the plane to the airport is 6,314 feet. I'm going to show on the video what that little trick was right here, okay, because I don't want them to be confused. Okay, so on that step, guys, what we can do is cross multiply, right? And we get x times tangent of 29 equals 3,500. And then we can divide both sides by tangent of 29. And you can see that it's like the x and the tangent of 29 just traded places. Okay, so that wasn't like some math voodoo. That's like just multiplying and dividing both sides of the equation by the same thing. Okay, let's do this one. An ice climber stands at the edge of a crevasse that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. Okay, a crevasse is like a canyon type thing, right? So I've got a little ice climber. Okay, she's up here on a little ledge. We know that the ledge or the crevasse is how wide? How wide? Okay, 115 feet. Okay, what is the angle of depression from the edge where she stands to the bottom of the opposite side? Okay, so the angle of depression goes from the horizontal, okay, down, and it goes from her feet down to the bottom of the other side. Do I need to go back and wait for everyone to catch up with, or just pause? Okay. So what is that angle of depression from the horizontal? Yeah, 52. Okay, how deep is the crevasse at this point? And we have to round to the nearest foot. So the depth is this right here. You see how we have a cute little right triangle? So we can just call this D for depth. So let's start labeling stuff. Here's my hypotenuse, right? That's the long side across from my right angle. Opposite my 52 degrees is my depth, right? Opposite the 52, this is my opposite side. And touching my 52 degree angle, my adjacent side is the 115 degrees wide crevasse. This is the adjacent. So we don't really need the hypotenuse for this because it's not our given information and it's not our unknown. So it's just garbage. So which of our trig functions relates the opposite and adjacent? Yeah, tangent. Okay, so the tangent of 52 degrees equals, yep, our D, our depth over our 115 feet wide. Okay, this time, again, thankfully, our unknown is in the numerator, so all we have to do is multiply both sides by 115. So D equals 115 times the tangent of 52 degrees. We can put that in the calculator. 115 times the tangent of 52, right? I can't look at my paper at the same time, and my short-term memory sucks.
It's 147.
Okay, what does it say to round to?
Nearest foot.
Nearest foot, yes. Okay, 147 feet. Looks good. Okay, so depth is 147 feet. Okay, now we have to write a sentence. The crevasse, it's a fun word to say, is 147 feet deep at that point. It's like a crack or like canyony thing. I don't know if it's as big as a canyon. It's like bigger than the. Yeah. No. Like canyony. Okay, they just Google fact checked me and trying to say that I was saying crevasse wrong, and I was right. So I'm really happy right now. All right, here we go. Is this the last one?
Yeah. No.
Oh, there's more.
Can we just do this one as well? For real.
Um,
Do this as the last one. Actually, why don't we?
I don't know. I'll have to look. Okay. So suppose the ranger sees another fire. Another fire? How many fires are there? Sees a fire and the angle of depression to the fire is 3 degrees. What is the horizontal distance to this fire? Okay, so the ranger is up on a tower. Okay. Here's our little guy. He's up on a tower. Now, what do we know about these two parallel lines? Well, they're parallel. Okay, so what do we know about this angle and this angle? They're congruent because they're alternate interior angles. So if that one's 3 degrees, then so is this one 3 degrees. And we need that because the angle of elevation is the one that's in our triangle, right? Okay, so this one's 3 degrees. Okay, we've got 90 feet. So from my 3 degree angle, well, this one is always the hypotenuse no matter what. What is the 90, opposite or adjacent? Opposite. And then x is my adjacent. Maybe we just set this one up. Okay. And so we're going to say that, did you say tan?
Mm-hmm.
The tangent of 3 degrees equals our opposite 90 over our x. And how do we get x out of the denominator? We can switch these spots on the diagonal, right, of the equation. Okay, so that would be x equals 90 over tangent of 3 degrees. And you can do that on your calculator and write a sentence, but we don't want this video to be forever, so we're going to keep moving. Questions? Okay. Oh, geez.
No, you want to skip it?
No, I feel like it's so painful we got to do it. Because what if there's one like this on your test, and this is the one I skipped? Okay, an observer in a lighthouse is 69 feet above the water. He sights 2 boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. I don't think we need to do this one.
There's another one.
Yeah, we're not going to do this one. Okay, video's over.